Alright, for 2.6 day 2, we're actually going to fill out this Justifications cheat sheet. We're going to be using this throughout the rest of the year, so I want you to have access to this rather than to have to keep your notes from Chapter 2, Chapter 3, Chapter 4. So this should be a green sheet. It was handed out in class. We're going to start with the addition property. So this is just a quick reminder of these things that we need to go through. So I'm going to press pause, write them down, and then you can press play and then get them down. Alright, so you're going to want to press pause, make sure you get these written down, and then I'm going to move on to the reflexive one down at the bottom. So a reflexive property, remember that's our mirroring. It's seeing something on the same side. So we would have A equals A as an example of that one. Again, I'm going to press pause, take a minute, write these down. Alright, the last ones here, we have symmetric. If A equals B, then B equals A. Transitive, if A equals B and B equals C, then A equals C. Substitution, if A equals B, then B can replace A in any expression. Our given statement is the reason for step 1 in the proof, and simplify is what we write as a reason when we combine like terms. The last few that I wanted you to fill out are angle bisector, midpoint, and congruence, along with the definition of right angles. So go ahead, press pause, write these ones down. And the right angles is the symbol you see in the corner is red. They're also complementary, perpendicular, or makes 90 degrees. These other ones we've seen as well. These are not new to us. So two lines are perpendicular if and only if they meet to form right angles. Vertical angles, no, we're not doing that one. So definition of complementary is two angles make 90 degrees, and the next one is two angles form to make 180 degrees. These ones we are actually going to talk about in the next lesson or so I'm just going to give you them. So we will write them down now. So the angle addition postulate, sometimes it looks like this, and we would say the measure of angle 1 plus the measure of angle 2 equals the measure of angle, and then we're going to do a little diagram. So we have A, so here we have angle 1 and angle 2, and this is going to be A, this is going to be O, and this is going to be C. So we see that if we put two angles together, we actually get the measure of angle AOC. And then we'll have segment addition, so this is when we have parts of a line. So let's say we have DE and F. So we can say something like this: DE plus EF is going to equal DF. We'll be talking about these ones coming up in 2.7. Right angles theorem says that all right angles are congruent. And the vertical angles are congruent. We talked about this before. I'll just draw an example here of vertical angles. Here we would have these two would be considered vertical angles, and then angle 3 and angle 4 would be considered vertical angles. Alright, that's the end of this little notes section. You guys are going to work on 2-6 day 2. And please keep this sheet so that we can refer to this as we move on. You'll notice on the back side, these are other theorems that we're going to learn about, postulates and theorems we're going to learn about in further chapters. Thank you. Bye for now.